hampir sama dengan AI in computer vision juga, sebab computer vision adalah satu field yang kita akan train models untuk detect apa objek yang dalam image. So, jadi izinkan saya guna bahasa Inggeris sebab saya perlukan slide saya dalam bahasa Inggeris dan ia akan memudahkan saya untuk memberi ucapan. So, I'm going to start with what is AI. AI is basically, I believe, many of you already know what is AI because it is very hot right now. It is basically artificial intelligence. And for my stance, I can make it 4 simple words. It is basically AI is when we use computer to simulate human intelligence. And that is one of the simplest form I can describe AI. Of course, there are formal definitions that you can find in Google or from other places about the real and formal definition of AI. But this is basically what it means. It is when we want the computer to have the same intelligence as humans do. And how about AI algorithm? This is basically when we program the computer so that it can learn how to do things by itself instead of we program it explicitly to do the task. So that means it acts like human being. You can teach the computer, and then later on, after the training, it can do the things instead of directly program the computer to do the things directly. So let me give you one example. Let's say we have 2 animals here. The first one above is one animal, and there's another animal below. So if I ask you which one is a cat, I think most of us, and maybe all of us, should know that the one above is a cat, not the one below. So the question comes is, how do we know that? So how do we know the one above is a kid? Sorry, it's not a kid, a kitten. Yeah, a cat. It's because we learn this from since we are children. So our parents teach us, our school teacher also teach us. This is a cat. C for cat and F for fish. So we grow up and then we get know to it and we get used to it, and that's how we know it. But if you are taught that since the beginning, if this is the one above is fish and the one below is cat, and you will grow up and you will get used to that as well. So it is basically what we learn is what we know after we grow up. Now we also try to teach computer the same thing. We want to teach the computer how cats looks like and how fish looks like, but not directly program the computer to recognize them one by one image. Instead, we want to program the computer so that it can learn by itself how cats look like. But we face a problem. There are many possibilities a cat can look like. For example, you can see this one is a cat smiling. I suppose that is smiling. And the one in the middle is the cat looks surprised. And the one at the right is the cat looks very sleepy. He is yawning. So this is just 3 examples a cat can look like. In reality, we have infinite amount of possibilities. We don't know how the cat will look like in reality, with different types of postures, different types of facial expressions, and different types of species and different colors. So to recognize all these cats as cats is actually very challenging if we try to program it manually using programming. So that is why we need AI, because AI is we program the computer so that it can learn by itself, just like human being. It has the intelligence, the ability to learn, and then to apply the knowledge that it learns. And then how we do that in AI is that we are going to teach the computer by showing the computer a lot of images of cats, maybe thousands of images of cats, and thousands of images of fish. And that is the phase we call training. We train the computer to recognize how cats looks like. It learns by itself how cats should look like and how fish should look like. And after the training, we show the computer another image that it has never seen before, and we are going to test it to see whether it can now recognize the cats and the fish or not. And that is how we do things using AI, especially in computer vision. So let me introduce you one data set which is called ImageNet. So ImageNet is a database. A database is a platform where you can download a very large amount of images that people has already collected. So somebody collect the images of animals, plants, vehicles, and a lot more other objects. In total, there are 1,000 objects inside the database. Each object has a lot of images. It can be billions of images. For example, billions of cats, billions of fish, and a lot of other objects as well. In total, it contains 14 million images. So that is a lot of images. So this database is actually collected by a lot of people, but the leader is Dr. Fei Li from United States. So she is the one who lead the team to collect those images. So that we have a database, and she make this database free. Everybody can download it, and the database name is ImageNet. And this ImageNet is very important because now everybody can download the database and train their own AI model. Otherwise, you need to collect the images yourself. You need to collect a lot of cats. You need to take pictures. You need to go and take pictures of cars, a lot of different objects to train the AI. So with ImageNet, we can now freely download the images and then train our AI. So this is very important because it pushes people to do competition, to compete who can create the best AI model. And it is also heavily used for research, for people to research how to improve AI models by training using this database. And then it is also used for transfer learning as well. So you may ask me, what is transfer learning? In simple terms, we call transfer learning is when we train a model that has been trained to do another task. So for example, somebody download the ImageNet database and then they train their own AI model. Now that model can only detect fish, cats, and vehicles, cars, keyboards, laptops. But maybe it cannot detect cancer cells. So what we do is we take the model that they have trained, we retrain it again so that this time it can detect cancer cell. Why we do this is because this saves the time. Instead of you train the model from scratch, that means from zero, it is going to take a lot of time, and to reach high accuracy, it takes a lot of images as well. So with transfer learning, we can save our time and save our training images, save our effort. So that is why ImageNet is very important, because it allows people to train the model from scratch first, and then the rest of the people just need to take the model and then train it again. We call that fine-tuning. So that they don't have to train from scratch anymore. Just take the model that other people have trained and you retrain it to do the task that you want to do. So this is basically how the transfer learning works. You can see the one above is when we train from scratch, you train the model only to detect dogs, for example. But transfer learning is when you train the model, you retrain the model that has been trained previously. Now it can only not only detect dog, but also cats. Now, this one is AI is actually applied in many fields. One of them is computer vision, which we are going to talk about today. And there's another field called natural language processing, which is very hot. I believe many students know about ChatGPT. That is chatbot, and that belongs to the field of natural language processing. The computer vision is different field. It only process images and videos. So in computer vision, we have three big algorithms. The first one is image processing. This one is very old already, but it's still used sometimes today. Image processing is basically, I believe that a lot of females love to use some filters to blur the image, to sharpen the image, to make your selfie looks better. That is one of the image processing methods. And we also have traditional machine learning methods. This one is also a little bit old, but it is still used today. How it works is you extract the features from the image first, and then you feed the features into a model, a machine learning model, or we call the AI model for training. But there is a problem with traditional machine learning. You need to determine what features to extract, and that requires expertise actually. So that is why deep learning is invented, and this is one of the most heavily used method in computer vision now, which is by using deep learning. This one is you directly feed the image. For example, the cat's image and the fish image. No feature extraction needed, no image processing needed. You directly feed into the model for training. So this is one example how image processing looks like. You can see the left side is a zebra and the right side is the zebra that is blur. We call that blurring. This is an example of image processing. And this is traditional machine learning. You have the input image and somebody, which is you, which must be an expert, is going to determine what features to extract. And once you extract the features, you put it into a machine learning model for training to recognize the fish and the cat. And deep learning is end-to-end. Everything is automatic. No manual feature extraction needed. So directly feed in the inputs, and then you are going to train the model to directly recognize the fish and the cat. So using computer vision, we can actually achieve three things: image classification, object detection, and image segmentation. So what are those things? You can see the first one is image classification. It is basically when we want to classify an image to a class. For example, is this a dog? Either yes or no. So that is classification. But sometimes we want to know the location of the object, not just to know whether an object is present or not inside the image. And we need object detection, which is the one in the middle. You can see now we have a cat, a very cute cat, and a very cute dog here. So the model is able to draw the bounding box, the box which is the region belongs to the cat, which is the yellow color, and the red color box represents dog. So this method is called object detection. It is done by using the computer vision model as well. And sometimes you might think this is not sufficient because I want to know the exact outline of the object, not just the estimated region using a box. So in that case, you can use image segmentation. This one is going to classify all the pixels into a certain class. So you can see the yellow color region represents the cat and the red color region represents dog. So this is image segmentation. So with so many computer vision and the AI use, how does it benefit to Sarawak? Actually, we have some of the computer vision AI models that has been used in Sarawak. For example, this one is still heavily researched. I won't say it has been fully matured yet because a lot of improvements still needed in this field is when we train the AI model to be able to detect eye disease. So I believe all of you know the disease called diabetes. So diabetes is actually going to cause your eye to go blind if it is very severe. We call that diabetic retinopathy, which is a stage when your eyes is getting blind by the disease called diabetes. So why it goes blind is because your eye blood vessel will explode and causing exudates microaneurysms, and we sometimes grow abnormal blood vessels called neovascularization. So that is a medical side. But in computer vision and AI, what we do is we create a model, AI model that can automatically detect the disease, so that the doctors don't have to spend a lot of time and effort to analyze the image, so that everything can be done automatically and faster. And this one, I believe all of you must have seen this. This is a lot right now in Sarawak, especially in the roads from Cebu to Bintulu or Cebu to Kuching. I'm not sure if there is, but I'm pretty sure this is quite a lot already, and some of you must have seen this. Is the vehicle speed detection. So whenever you drive your car pass by, this machine can detect what is your speed. It seems very magical, but there is an algorithm behind it, and we use computer vision as well. So how it works is when we drive the car, there are two lines that the camera has already set properly, the red color line and the blue color line. Now the machine is going to detect cars. There is a model, AI model that can detect car. So when the machine detect your car, pass through the red color line, let's say this is the left side, the road from front to back, your car is driving from the back to the front. Your car is going to touch the red color line first, and then the machine detects that. He realized you touched the red color line. And what he do is the machine is going to start counting the counter, how long it takes for you to reach the blue color line. And once you have touched the blue color line, so this is the time taken for you to go from red color line to blue color line. So what the machine do is simply take this distance between the blue and the red, which has already been calculated, pre-calculated before, set properly, and take the distance divided by the time taken you reach to the blue color line, and that is how the machine estimates your speed, because our speed equals to distance divided by time. And from there, the machine can know what is your speed. And this one is Bintulu, the Spring shopping complex, and Kuching also got some shopping complex. The one below at the car park there, you can see there's an automatic car plate detector. Nobody is standing there to record what is your car plate. Everything is automatic. You just drive there and stop a while. The camera is going to take a picture, and then it can automatically know what is your car plate. So this one is also done by using computer vision as well. So what it does is there is actually two AI models behind there. The first AI model is going to detect your car plate first. Once it detects your car plate, the second model is going to detect the characters, the alphabets and the numbers inside the car plate. And from there, the machine is able to know what is your car plate number. So what are the advantages of having such systems and such machines in computer vision? We do that so that we can reduce the human error, because when somebody needs to stand there to record your car plate or to record your vehicle speed, or the doctors need to spend their time to analyze the images of the medical MRI scans, this is going to get the human to get tired and possibly prone to human error sometimes. So if we have machine that is very accurate, of course we need an accurate machine, we can minimize the human's error, and it is 24/7 availability every single day. Nobody needs to stand there or have a shift work to get the job done, and it can make decision very fast, because the analyzation is done by using computer. Everything is automatic and fast. Compared to human manual work, human sometimes takes more time than machine to do the things. But the problem is the computer is not able to think creatively. It cannot think outside of the box. It can only do based on the training data that it has been trained. And the cost to create such system, such as AI model, is very expensive. Like for example, the database, you need to collect it and take pictures, and then you need to label the images. Sometimes it cannot be done by just one person. You need a team to collect the images and label the images in order to use it to train the model. So that is going to take a lot of money to do that. And sometimes when you develop such system, you are going to challenge the workers that has been doing the job for decades in the field. So it might lead to unemployment because your system can replace people. So that is going to be one of the disadvantages as well. Okay, so this is the software that we usually use to train the AI models. I'm going to demo to you one instance how we do that usually. So you don't have to get into very technical, very detailed. You can just watch what I do and then to get the idea how we train the models. So we use Python and we use a Visual Studio Code to do that. So if you have already know Python, then you should be very familiar with the syntax used in the machine learning. But I'm not going to go into very much about the programming. I will just demo to you how we train the models. So just in case, if you are interested in the tools and the scripts that I use in the demo, you can scan this QR code to download the files and to download the training images as well that I'm going to show you how to do it. But you don't have to do it now. You can do it later at the home after you see how I do the things. So I will give you around 50 minutes maybe to scan it. Okay, so you have scanned that if you are interested in downloading the files. Else, it's okay if you don't want to do so. There's no force to do that. So let me open the folder. So once you are inside there, you are going to see my slide as well. You can use it for reference if you like it. And there's a file called YOLO, Y-O-L-O here. So this is a folder that you can use. So when you open that, you can see a lot of files inside there. That is not very significant to know all of them. But let me show you the data folder. If you open the data and the images folder, and the train, that means the training data, you can see there are a lot of images that I have collected here. There is a cat image here, a very cute cat. And then there is, more cats. More cats here. So these all images have already been labeled. We have already labeled this image one by one by drawing the box, cat, cat, and cat, just that it is not shown here. And we also have dogs as well, puppies. Yeah, this one. So this is a dog, and we have a cat. It is also labeled. All the labels can be found inside the labels folder. So you can see, yeah, these are all the labels that we have prepared. So what we are going to do is we are going to teach the computer that I'm using now, which is my laptop. I'm going to teach this computer how to recognize this cat and the dog. And then we have test images. After we train the computer, we train the machine, we are going to test the machine whether it can recognize cats and dogs or not. So these are the testing images. These images is not present inside the training data. So that means the computer never seen this image before, so that we can ensure the computer can really recognize the cats and the dogs. So to do that, first you can try, what you can do is you can open the train.py, this file right here, and then I need to key my password. And first thing you need to do is you need to install the library. So let me do that. So what I'm doing is I'm installing the libraries as stated in the requirements. So what is this? All of this is the libraries that we need to use in order to train the models. So please give me some time to install the libraries. And it is still installing, collecting packages. Okay, so this means the library has been installed. Now we can run the training code, the training script to train the model. So I'm going to train the model by using Python, train.py. So what happens here, the training is going to start. So yeah, this means the training has started. It is starting to run. That means what happens here is the computer is going to go in this all images one by one, each one by one until the last one. Where is the last one? Oh, so many. I suppose that is 1,000 plus images until the last one. It will learn how the cats and the dogs look like. It will say, oh, this is a dog, and then it will learn that it's a cat. Where we have the cats, the cats should be above. All of this is dogs, and the cats should be the region above. Yeah, this is cat and dog. Even the background is also learned. So this is the back. Yeah, they will learn this is dog and this is cat. You will learn one by one, and once it gets to the last image, it will repeat again. Go back to the first one, this first one, and then go to the last one and repeat and repeat. How many times it will repeat? It will repeat for 30 times. So you can see this is the sixth time it repeats the images. 6 out of 30. So it will go until 30 to make sure it learns the image, it learns the cats and the dogs properly to make sure it is accurate. So we are going to the number 8 cycle, which we call epoch. And we are going to number 9. It should take a little bit time to reach 30. Okay, we are reaching 15, which is halfway already. There's 15 more to go to reach until 30. <clears throat> 5 more to go. It's 25. 27. 29. And the last one, 30. And that is going to stop the training. Okay, so it's finished. Yeah, there we go. Now the training process has done. We have trained the computer to recognize cats and dogs. So where is the model located? It is actually inside this runs folder. This folder will be automatically created after you start the training. So inside here, I can see there's best.pt. This best.pt file is the AI, is the AI model that we need, that we are going to use to detect cats and the dogs. So let me copy this out, put it outside here. So I'm going to put it here. So now this best.pt is right here. Then what I'm going to do with that, I'm going to use it to detect cats and dogs using the test images. So these test images is the machine has never seen before during training. So we are going to feed these 3 images and to check whether it can successfully detect the cats and the dogs or not. So to do that, I'm going to open my detect.py, and what I'm going to do is that I'm going to make sure my file path is correct, which is inside the test images folder, and the file name is test1.jpg. Let's double check that. Test images, test1.jpg. So this is the image that I'm going to use. So to do that, very simple, just run the code. So Python 3 detect.py is going to run the script. And once that is done, you go out there, you are going to see a new image created. It is called output image.jpg. So when we open that, now you can see it draw a box here, green color box, and then it says that is a cat, C-A-T, cat. And the right side here is a dog, so it draw a box there, and then it writes dog. So yes, the AI model is accurate in this image. It successfully detect the cats and the dogs. And let's give a try to the second image, test2.jpg. So this is the image that we are going to try. The file name is test2, so that means I need to modify this test1 to test2.jpg. And simply just run the code again. Then we go out. Now this output image.jpg has been modified. We can open it to double check. And yes, it draws it correctly. This is a dog, and that is a cat at the right side. It draws the box correctly and label the box correctly. How about the third image? Let's give the third image another try. So that will be test3.jpg. And the third image is, yeah, the left side is the dog and the right side is a cat. So we check whether it do things correctly or not. So yeah, you can see the output image has been updated right here. So I'm going to open that. So you can see, yeah, it correctly draw this as dog and this as a cat. So bear in mind that this dog and this cat, the AI never seen before. He never see this dog before. He never see this cat before during the training. All the training images doesn't contain this kind of dog and this kind of cat. So that means the model can now be used to detect cats and dogs. You can take the camera and bring your machine out and just take videos, and then the model should be able to recognize the cats and the dogs. Of course, sometimes it still makes mistake because there are some puppies looks very cute and still looks a bit like a cat, and that is going to confuse the AI as well. So this is how we usually train the AI in computer vision to detect the objects. So hopefully hopefully you get the overview how the computer vision world is like, and this is what we do most of the time in the computer vision professions, and we do train models to detect the cats and dogs. And this is just one example of cats and dogs. Sometimes we do something more seriously that is more important and more useful to the society. For example, we are going to train the model to be able to detect the cells that is not normal inside the MRI scans, or maybe we detect cancer cells is one of the very popular, or brain tumors. For example, if you have tumor inside the brain, and then you go to the doctor there, the doctor is going to scan your brain, and then the doctor need to analyze where is your brain tumor, or whether you have brain tumor or not. But with this AI computer vision, we can train the model, we can train the computer to recognize the brain tumors and detect where is the location of the brain tumors. So that when the doctor scan your brain, the system automatically tells where is the brain tumor, so that the doctor don't have to search for it. It takes more time to search and to analyze the image. Everything can be done automatically. So this is one of the useful example of application of computer vision instead of detecting just cats and dogs, because this is just one simple example. So I suppose this is going to make it easier to understand, because people understand animals better than the cancer cells. Not everybody is doctor. Even I cannot recognize the cancer cell as well. We need doctor to be able to analyze those images. So I think that's all for me for my presentation and my demo. I have finished this demo and my presentation. So I would like to open to questions. Do you have any questions for me?
Again, morning, doctor. Can you hear me?
Yeah.
Is it possible to scan multiple file at once? Like
Yes,
you do just now, it's one by one.
Yeah, correct. Yes, it is possible to scan multiple files at once, but you need to do the programming already. because the script is written just to detect one file only. So if you want to detect multiple files, you need to modify it so that it can read all the image in a folder and then one by one feed into the model that we have trained and produce the output. The output save it in another folder, for example. And later on, you open that output folder. It is all the output images from the input folder. You can do that, but some modifications need to be made. And you can definitely download the scripts and the training images as well. Everything is inside the QR code I gave you. You can just download it from there and play with it.
Okay. Morning.
Good morning, sir.
What's it?
Yeah, good morning.
Sir, I have a question. To us to verify either the data set is strong enough or not, should we see on the F1 score of the model if we are training on a preset model?
Can you repeat one more time? I cannot get it.
Good morning, sir. So my question is, if we are training on a preset model, right? Should we see on the F1 score to verify our data set is strong enough?
Oh, F1 score. Yeah, very good. Wow, you know about those metrics already. So F1 score is very useful when the data set is not balanced. That means if your test data, the balance of the data is referred to the testing data, not the training one. So the testing data, let's say you want to test the model, you have trained it. Now this testing data contain images not present inside the training. It's different, two different sets. So if your testing data is not balanced, that means you have a lot of cats, but only a few dogs. So this is not balanced. We have to use F1 score to measure it, not and don't rely on accuracy. Why? Because if you rely on accuracy, your model can detect all the dogs correctly. Let's say you have 80 dogs, you have 20 cats. Your model detect the 80 dogs all correctly, perfect. But the cat all is wrong. Your model says all the cats is dog. So 20 is wrong, 80 is correct. Your accuracy is still 80%. So it gives you a false sense of accuracy that your model is accurate, even though your model is wrong when detecting the cats. All the 20 cats is wrong. Your model says it's dog. So that is when we use F1 score. Yes, F1 score is very useful if your testing data is not balanced. The animals or the object's number is not balanced. But when the object is quite balanced, for example, you have 50 dogs and 50 cats, then accuracy is a very good metrics used for measuring how accurate your model is. So you mentioned that should we use F1 score? It depends on the situation. If the testing data is not balanced, the classes is not balanced, number of animals is not balanced, we need to use F1 score. If the animal is balanced, then it's okay to use accuracy. But if you still insist to use F1 score, it's still okay as well. No, there's no huge problem as well. But the problem comes with you need to collect the images for testing. Just now I only have 3 images, so that cannot measure accuracy. Do we have any more questions? So I think if we don't have questions, I will pass to the MC.
Dilihat selama 30 minit, kemudian akan terus dengan ceramah yang kedua. Kita belajar dulu dahulu untuk announcement seterusnya.
All right, thank you, doctor.
Okay, thank you very much. Thank you.